This video is on the equation of a line. The equation of a line is a rule that connects the x and y coordinates of all points on that line. Now there are three different forms of an equation of a straight line that the IB could ask you to use and that are valid equation forms. The first one is the gradient intercept form, which is y equals mx plus c, and that's the one most commonly known by most people. In this one, the m is the gradient and the c is the y-intercept. The second form is the general form, which is ax plus by equals d, or ax plus by plus d equals 0. This can depend on which textbook you're using and how you look at it. The IB uses second version with the equals 0. In their formula booklet, that is the one that is utilised. Now, in this form, a really important part is that a, b, and d are required to be integers, and majority of the time, a must also be positive, but just read the question with the requirements around that with what they would like. But the main thing is that a, b, and d cannot be fractions or decimals, they have to be an integer. The last one is the point gradient form, which is y minus y1 equals m, bracket x minus x1. Now with this form, we can always rearrange this equation to either one of the other forms, and that is why this third one is actually my favourite, and it's the one I will utilise more in the examples than the other two. As for this one, you just need the gradient at 1 point, sub it in. If it doesn't tell you how to give your answer, that is a valid answer. If it does want you to rearrange it, then from there you can just do your rearranging to either the gradient intercept form or the general form. Now to determine the equation of the line, we need to know either the gradient at 1 point on the line or 2 points on the line. We need either of those to be able to find the equation of it. First example, finding gradient intercept form, the equation of the line with a gradient 5 that passes through -1, 3. Gradient intercept form is our y equals mx plus c. That's the form we are wanting. Now I'm going to use the point gradient form to start with. It just minimises errors happening. I'm going to start with this one. And then from here, I'm going to sub in my information. So I have a gradient of 5, which means my m is 5, and I have my point. So that will be my x1 and y1. And let's sub that in. Look at y minus 3 equals our gradient, which is 5, and x minus 1. Here then I'm just going to simplify inside the bracket. So it'll be, because we have a minus 1, so it becomes a plus 1. Now to put it in the form y equals mx plus c, the first thing I am going to do is expand the bracket because there's no bracket in the solution, which will give us y minus 3 equals 5x plus 5. And then I'm just going to add the 3 to the other side because we have a y minus 3. So to get rid of the minus 3, we need to add 3. And therefore we'll end up with 5x plus 8. And now we have our answer in the gradient intercept form. Example 2, find in general form the equation of the line with gradient 3/4 that passes through 5, -2. General form, that is the ax plus by plus d equals 0. I'm going to do it in this way because that's how IB would expect it to be done. But once again, I'm going to still start with my point gradient form. And I have my gradient, which is 3/4, and I have my point, my x1 and my y1. And so I can substitute them in. We'll have y minus 2 equals our gradient, 3/4, upper bracket, x minus 5. Now from here, there's different ways to rearrange this and to get it into the form ax plus by plus d equals 0. Now it's remembering in that form, we cannot have a fraction. But here my gradient's a fraction. So what I would like to do here is get rid of the fraction first to make it simpler. It is also to note here that the 3/4 times x minus 5 can also be written as this 3 times x minus 5 on 4. They are the same thing. So if I want to get rid of that divide by 4, all I have to do is multiply by 4 to both sides, which means we'll end up with 4 bracket y plus 2 equals 3 bracket x minus 5. Now I've got rid of a fraction, it makes expansion and rearranging just a little bit simpler. Expand the bracket, 4y plus 8 equals 3x minus 15. And then we just want to move everything to the one side of the equation. I have positive 4y on the left-hand side, so we'll have minus 4y on the right-hand side when we move it across. We have minus 15 and To move the plus 8, we need to minus 8, and then just simplify that, and we'll have 3x minus 4y. 15 minus 8 is minus 23. And now we have it in that form. Example 3, find the equation of the line with a gradient 2/3 and it passes through 5, negative 2. In this question, it doesn't tell us how to give our answer. It just says find the equation. So any of the three forms is valid. So here I have a gradient and I have a point. So I'm just going to use the point gradient form. The y minus y1 equals m bracket x minus x1. Substitute in y minus minus 2 equals our gradient, which is 2/3 bracket x minus 5. Just simplify the left-hand side, we'll have y plus 2 equals 2/3 of x minus 5. And that's it. That is the answer. There's no more rearranging or anything needed. And that's why I really like this form, because if it doesn't tell us how to give an answer, it's really quick. Example 4, a circle has centre 2, 3. Part A, find the equation of the tangent to the circle with pointer of contact at negative 1, 5. So I'm just going to quickly draw a circle here. The centre is at 2, 3. Now it says find the equation of the tangent to the circle with the point of contact at negative 1, 5. So negative 1, 5 would be to the left and above 2, 3. We want the tangent at a line. Now remember, a tangent is a line that just touches the circle at one point. And that point here, we know is negative 1, 5. Now we want the equation of that tangent. So we've got to think about how can we do this? How can we find the gradient of that line? Because we only know one point on that line. But what we do have is this line here that we can draw between C and the point on the tangent. Now, if we look at this blue line here, it is perpendicular to our tangent, which means it makes a right angle. And previously, we have looked at the gradients of perpendicular line being the negative reciprocal of the original line. Now, our original gradient would be the gradient of the line that joins P and C. So the first thing we need to do is find the gradient of CP. So we have our 2 points of 2, 3 and negative 1, 5. And we'll have our x1, y1 and x2, y2 to put into our gradient formula. Remember, y2 minus y1, which would be 5 minus 3 over x2, negative 1 minus x1, which is 2. Solve that and we'll get 2 over negative 3, so negative 2/3. Now the gradient of our tangent is going to be the perpendicular gradient of this because the line's at a 90-degree angle to the line with this gradient. And then remember to do that, we flip the fraction, so the 2 over 3 will become 3 over 2, and we change the sign. Now the fraction, the original gradient is negative, which means our perpendicular gradient is positive. And now we can sub that into the equation of our line. Because we have a gradient and we have a point. Now, we have to make sure we're picking the right point. The point on the tangent line is negative 1, 5. So we have to sub in that point. We can't sub in the centre because that would be a different line. And then we'll end up with y minus y coordinate, which is 5, equals our gradient, 3 over 2, x minus our x coordinate. And then we can just simplify that to y minus 5 equals 3 over 2 bracket x plus 1. Once again, doesn't tell us how to give our equation, so we can just use that one, and that's our solution. Now part B wants us to find the equation of the normal to the tangent. Now if you don't know what the normal is the line perpendicular to the tangent, which means in our little diagram we've got here, that would be actually the blue line we drew, the original line between C and P. That is our normal to the tangent because it's a line at a right angle to the tangent line, which is the pink line, which means we already have our gradient because we found that before at the start of part A, which was negative 2/3. And now we need a point to sub into our equation. But we actually have 2 points on the line. We have the P and the C. So you can pick either of those to substitute in. Doesn't matter which one you use, you can use either. So you could use negative 1, 5, or you could use 2, 3. And both answers would be correct if we just put it into our point gradient form. So we'd have y minus 5 equals our gradient, negative 2/3, bracket, that would be x minus minus 1, so x plus 1. Or if we subbed in the second point, the 2, 3, the centre, we'd have y minus 3 equals negative 2/3 x minus 2. And what you would find is if you expanded those two equations and rearranged them to one of the other two forms, you would get the same answer. Example 5, determine whether the point 513 lies on the line. To do this, we need to just sub x equals 5 into the equation of the line. And then if the answer is 13, then it is on the line. So we'll do y equals, we've got 3x minus 2 is our equation. We'll sub in the 5, so y equals 3 times 5 minus 2, which equals 15 minus 2, which equals 13. As it's 13, therefore, it is on the line. It's that simple. And that is the end of this video.